Welcome to The Deep Dive, the show that meticulously unpacks complex topics, distilling them into surprising insights and, well, actionable knowledge. Today, I want you to close your eyes for just a moment. Picture a truly magnificent structure. Maybe it's an ancient Greek temple, its marble columns gleaming under that Mediterranean sun. Or maybe a colossal Roman aqueduct stretching across valleys, just defying against time. Or even a gleaming futuristic skyscraper piercing the clouds of some bustling metropolis.
Incredible images.
Each one, in its own way, represents an incredible feat, right? But have you ever really stopped to ponder how such a complex, abstract idea, something born from a spark of imagination in someone's mind, actually transforms how it becomes a physical, tangible reality?
It's a journey that's just monumental, woven from threads of ingenious communication, meticulous craft, and, frankly, sheer human will.
It really is an intricate dance, wouldn't you say? A process far more elaborate and I think fascinating than most people probably ever realize.
Definitely. And in this deep dive, we're not just going to skim the surface. We're going to journey through centuries of architectural and construction evolution. We'll explore precisely how that initial design intent, that pure vision, has been translated into the robust, built reality we interact with every single day.
Yeah, we'll start right at the beginning, uncovering the foundational principles of those ancient builders.
Then track the profound rise of standardization, regulation, all that necessary stuff.
And finally, marvel at the truly transformative power of our modern digital tools. It's quite a sweep.
From the philosophical underpinnings that guided, say, Greek and Roman architecture, all the way to the precise data-driven world of building information modeling, or BIM, you're going to discover the enduring challenges and, maybe more excitingly, the surprising innovations that have shaped our entire built environment.
That's the core of it. And throughout this whole exploration, we'll be consistently wrestling with, one central question, really. How do we effectively communicate these incredibly complex design ideas to the diverse teams responsible for bringing them to life?
And crucially, what happens when that communication breaks down? Or perhaps evolves into something entirely new and unexpected?
Exactly. That really is the linchpin, isn't it? Because successful construction, from the smallest cottage to the tallest tower, it ultimately hinges on that clarity of communication.
It absolutely does. By the end of this deep dive, you'll gain a much richer appreciation for how every beam, every wall, every intricate design choice you encounter is a culmination of a long, unbroken history of human endeavor.
All aimed at bridging that fundamental yet profound gap between pure imagination and a tangible structural reality.
So consider this your shortcut to being genuinely well-informed on the grand human narrative of building. Let's dig in.
Okay, let's begin our journey. Let's travel all the way back to ancient Greece. This is where the very idea of design intent was so deeply intertwined with art, with reason, and with this, relentless, almost spiritual pursuit of perfection.
It's fascinating. The Greeks weren't just, erecting functional structures. They were crafting profound statements, meticulous expressions of advanced thought.
Yeah, you see it in what our sources call their acute intelligence, that delicate perception which knows how to turn every difficulty and every obstacle to the ultimate advantage of art.
Even in the most minute detail.
Exactly. They looked at every challenge not as a hindrance to just overcome, but as a unique opportunity to elevate their craft, to weave the solution directly into the aesthetic and structural fabric of the building itself. It's a different mindset.
It's a crucial distinction. For the Greeks, architectural order was never arbitrary. It was a deeply philosophical concept. It involved the precise placement of all parts in their necessary positions.
Purposefully placed.
Purposefully, yes. With the explicit goal of achieving an effect that was profoundly satisfactory to both pure reason and, importantly, the discerning senses.
Right.
And what's truly remarkable is their belief in a principle of harmony that was quite literally independent of the overall dimensions.
What does that mean exactly, independent of dimensions?
Well, it meant that the intrinsic proportions, the relationships between parts of, say, a portico, would remain constant and visually correct, whether that portico was 30 cubits high or a mere 10.
Okay, so the ratio is the key.
Precisely. The internal mathematical relationships of the forms were paramount. It was like a sort of universal template whose proportions would be faithfully reproduced irrespective of the overall size of the structure. This mathematical and philosophical rigor, this pursuit of an ideal form, was absolutely central to their concept of a perfect architectural order.
And their genius extended far beyond just the individual building, didn't it? It was about how that structure integrated seamlessly, almost organically, with its surrounding environment.
Definitely. Take Agrigentum, for example, one of
Hmm.
the finest Dorian colonies.
Hmm.
The selection of its site wasn't just practical, it was an art form in itself, absolutely integral to the overall design vision.
So how did they do it?
Well, imagine this. They observed these naturally occurring calcareous hills running parallel to the sea, instead of ignoring them or leveling them.
Which we might do today.
Right. They strategically transformed this natural feature into the city's rampart on its most exposed side. They didn't just build on the land, they sculpted it. They collaborated with it.
Wow.
The summits of these hills were shaped into formidable, thick walls, carefully pierced with gateways, and then majestically crowned by temples, creating this harmonious blend of defense and divinity.
And the city itself?
The city nestled securely in a valley, perfectly sheltered from the strong north and southeast winds that frequently swept across Sicily. It truly demonstrates a profound respect for and an intelligent manipulation of nature to serve both their artistic and functional goals. It's a symbiotic relationship between the built and natural world.
It's an incredible example of holistic design,
Yeah.
thinking about the entire urban fabric, not just isolated structures, and how it fundamentally interacted with the landscape.
Which makes me wonder about our own design priorities today. When you envision perfect design in our modern world, are we still consciously striving for this kind of intrinsic proportional harmony, this deep integration with the land?
Or have other factors taken over?
Exactly. Maybe speed of construction, cost efficiency, or even just the sheer novelty of form? Have those taken a more dominant precedence in our architectural priorities? It's a tension that's really echoed through the centuries.
That's a perfect springboard, actually, because if the Greeks were largely focused on intrinsic art and reason, the Romans, well, they had a profoundly different imperative.
Oh, absolutely.
Theirs was driven by monumental scale, unyielding function, and let's face it, unparalleled engineering prowess.
It's clear they weren't artists in quite the same Greek sense. They were rulers, administrators, and above all, master constructors.
Right. Their primary concern seemed to be the complete satisfaction of a practical requirement, whether it was for baths, aqueducts, basilicas.
Form, as one source so aptly puts it, was often merely an outer dress for their colossal functional constructions.
Just decoration layered on top of the engineering.
Pretty much. They were less captivated by those subtle mathematical harmonies that defined Greek aesthetics. They were far more concerned with the sheer grandeur and utility of the finished whole.
Look at examples like Agrippa's rotunda, lavishly decorated with marble, or the immense Caracalla's baths. These reveal a distinctly Roman inclination for magnificent display, for awe-inspiring scale.
Definitely. And even today, in their, forlorn nakedness, the ruins of Roman structures still profoundly impress us. They showcase the gigantic mechanism of their underlying structure.
Yeah, it's a testament to their engineering and administrative might, often more than to pure aesthetic taste, perhaps.
Perhaps. And nothing, for me, quite encapsulates that Roman genius like the Pantheon.
Oh, agreed. Incredible building.
Imagine the sheer scale of that immense, unreinforced concrete vault. A perfect hemisphere stretching 142 feet across.
Unreinforced, it's mind-boggling.
And at its summit, the single vast oculus, a 26-foot diameter opening. That's its only source of natural light.
Which casts that dramatic, ever-moving circle of light on the porphyry and granite pavement below. It's a spectacle of pure construction.
It really is. Where the decoration is the structure, with its dramatic interplay of light and shadow shifting throughout the day, it's a conceptual grandeur that perfectly illustrates their mastery.
It's a structure that speaks for itself, demands respect for its ingenuity.
And what's also incredibly fascinating here is how early they developed a kind of rudimentary, material science, even if it was largely empirical, passed down through generations.
Right, not labs and testing, but experience.
Exactly. Vitruvius, in his comprehensive writings, didn't just list materials. He meticulously outlined the specific properties of various stones, almost like he was describing their individual personalities.
Yeah, I like that.
He noted that soft stones, like certain limestones, were easy for masons to work and shape quickly, ideal for less critical architectural elements or interior finishes.
Makes sense.
But, crucially, he warned that if placed in open, exposed situations, they would quite literally crumble under the relentless assault of frost, rime, or salt.
So you had to know your materials and where to use them? Imagine the cost of getting that wrong.
Oh, absolutely. So it wasn't just stone is stone, but this specific stone for this specific purpose and environment. It's as if they had an intuitive, deeply practical understanding of a material's inherent strengths and weaknesses, a kind of builder's wisdom distilled over centuries of trial and error.
And they applied that across different types of stone.
Yeah. And then you have a material like travertine, that robust, cream-colored limestone so ubiquitous in monumental Roman structures.
Right, you see it everywhere in Rome.
Vitruvius praised its ability to withstand immense loads in the harshest weather. It was, in many ways, the unyielding workhorse of Roman construction. But even with travertine, he warned of its specific Achilles heel fire.
Interesting. Why fire?
He meticulously noted it would split under fire due to its very composition having little moisture or earth, but much air, and what he called fire, essentially its crystalline structure and how it reacted to intense heat.
Wow.
This wasn't just a casual observation. It demonstrated an early, albeit empirically derived, understanding of how specific materials would behave under intense stress and environmental extremes. A foresight absolutely crucial for building structures that would literally endure for millennia.
It really highlights that even without our modern laboratories and chemical analysis, their deep practical engagement with materials led to profoundly useful insights.
Absolutely. It's remarkable how far back that deep respect for material properties extends.
Which makes you think.
Yeah.
When you observe a modern construction project today, particularly one focused on achieving unprecedented speed or specific functional performance, do you start to see distinct echoes of that Roman approach? Are we still, in our own way, prioritizing sheer scale and utility over, say, pure aesthetic harmony, often selecting materials based primarily on their specific performance envelopes, even if it means sacrificing other more artistic qualities?
It seems like it sometimes. These ancient choices, whether the Greeks' pursuit of intrinsic harmony or the Romans' pragmatic focus on durability and function, they set foundational precedents that we continue to wrestle with every single day.
That tension between ideals, aesthetics versus utility, it's been a constant throughout history.
Indeed. And evolving from that Roman approach, we find a really profound revelation in the work of Viollet-le-Duc, the renowned French architect and theorist, especially as he meticulously analyzed Gothic architecture.
Right, the Gothic master interpreter.
He observed that Romanesque architects started to fundamentally move away from that distinctly Roman distinction between a structural body and a purely decorative dress.
Abandoning the outer dress idea.
Exactly. Instead, the construction itself became the architecture. Necessity, in a very real sense, dictated the form. This was a radical shift where structural honesty and the visible expression of forces became paramount.
It's as if the very bones and sinews of the building became its primary beauty and language.
Well put. He noted how, for instance, unable to erect those monolithic columns that were the hallmark of earlier styles.
Because the quarries weren't available or the transport was too difficult?
Right, so they built with low courses, creating square or round, short, and massive pillars. Or, with ingenious practicality, they clustered columns together, effectively dissimulating their heavy appearance while still providing the necessary support.
So the constraints weren't hidden or disguised.
No, they were openly embraced, integrated, and transformed into an integral part of the design language itself.
And Viollet-le-Duc's admiration for Gothic architecture stemmed precisely from principles that were, in his words, the result of experience and also of good sense and taste.
He meticulously highlighted how the exteriors of medieval buildings intentionally differed in their visual complexity from their interiors. On large facades, they multiplied projections and created intricate patterns of light and shade effects.
Designed specifically to engage the eye from various distances.
Exactly. This wasn't accidental. It reflected a sophisticated understanding of how a building is perceived both up close and from afar, and how it actively interacts with its changing environment throughout the day.
What I find truly fascinating here is their deep understanding of materials. It went far beyond merely knowing if a particular stone resisted frost or if steel endured tension.
Right. It was about the effect of the material.
Yes. For them, it meant understanding the profound effect produced by materials when used in specific ways. A stone placed on end, for example, conveyed a different structural and visual meaning than one laid in traditional courses. Similarly, closely jointed masonry was perfectly suited for forms that didn't allow for thick mortar layers. This concept of giving materials the function and strength precisely suitable to their purpose was not just a practical consideration.
It was core to the design.
It was a critical point in the very design of the building. embodying a visual truthfulness in construction where the material and its properties dictated a significant part of the aesthetic.
It was about letting the material tell its own honest story, so to speak. This holistic approach makes us really pause and question, does modern architecture consistently integrate material properties with aesthetic intent in such a fundamental way?
Or are we still, at times, simply dressing up a functional structure, much like the Romans with their outer dress, but now with different, perhaps more technologically advanced materials?
The search for that intrinsic honesty in building remains a powerful ideal, I think.
That's a powerful thought, this constant interplay. And perfectly bridging these distinct worlds, these different philosophies of building, was the extraordinary Andrea Palladio.
Ah, Palladio, a true synthesizer.
His work, particularly his iconic villas like Mazer, often represented, as our sources highlight, the best of two worlds. He brilliantly combined the hard-nosed practicality essential for a working farmer with the refined aesthetic sensibilities of a Renaissance gentleman.
He was a master of synthesizing the functional needs of a productive agricultural estate with the elegant, classical ideals of Renaissance design, making the beautiful also eminently useful.
He truly achieved a remarkable and enduring balance.
And in his urban designs, like the Palazzo Chiericati, Palladio made a bold departure. He rejected the then-dominant Roman Renaissance style for a distinctive tripartite division with a strong, determinate central focus. Crucially, this design wasn't conceived for a narrow, bustling city street, but rather for an open, expansive piazza, making it visually more akin to a villa in its relationship to the surrounding space.
So context was key for him, adapting the form.
Definitely. It demonstrates a clear evolution in urban design thinking, adapting classical forms not just to historical precedent, but to specific site conditions and the intended viewing distances, foregrounding context over rigid tradition.
And in his later, more mature works, like the magnificent Redentor Church in Venice,
Oh, stunning.
we see what are truly described as mature compositions. Here, the dome, the towers, the roof, the buttresses, they aren't merely added on, they are integrally bound to the facade, forming a unified, holistic, proportional system.
A system that's not only visible but profoundly understandable even from a distance across the Venetian lagoon. It's a masterclass in cohesive design where every single element contributes meaningfully and harmoniously to the unified whole.
And his legacy, of course, continues to captivate. His Teatro Olimpico in Vicenza, for example.
Still incredibly impressive today, an astonishing fantasy that enfolds the visitor in a past world.
And it continues to attract people globally, not just as a historical artifact, but as a living venue for classic drama, underscoring the timeless appeal of his synthesis of classical forms and theatricality.
It's a powerful testament to the enduring impact of a truly integrated and visionary design philosophy.
So for you, listening today, how do our contemporary architects balance these myriad worlds? The often conflicting demands of the client's vision, the physical constraints of the site, the harsh realities of the budget, and their own unique artistic vision, all within the framework of a single cohesive project.
It's a question of profound synthesis, isn't it? Echoing Palladio's enduring genius across the centuries.
Okay, moving on from those monumental ancient foundations, let's delve into what we can probably best describe as the hands-on era.
The age of craft.
A time unequivocally dominated by meticulous craftsmanship and the ingenious, often humble use of local materials. Before the profound shifts of the Industrial Revolution, building was an intensely artisanal endeavor, relying heavily on the home skill and accumulated knowledge of individual craftsmen.
Think about wood, for instance. It was just a foundational material, inherently strong, remarkably durable, surprisingly lightweight, and incredibly versatile to work with, always offering its own natural beauty.
Right. You had different types for different jobs. Softwoods like pine and fir were the stalwarts for general construction, abundant, easy to cut.
While the more exquisite hardwoods, things like cherry, maple, oak, they were carefully reserved for refined work, durable flooring, elegant paneling, intricate interior trim, chosen for their resilience and aesthetic appeal.
And the innovation wasn't limited to just selecting the right raw materials, was it? Even in these early periods, builders found incredibly clever ways to optimize and enhance their resources.
Absolutely. Take plywood, for example. We think of it as modern, but it represents an early form of engineered material innovation.
How did they make it back then?
Well, it was created by bonding thin layers or veneers of wood together under intense heat and pressure, typically with the grain of adjacent plies arranged at right angles to each other.
Ah, the cross-graining. That's the key.
Exactly. This ingenious cross-graining created a remarkably stable, strong, and warp-resistant sheet material, far exceeding the capabilities of a single solid piece of wood of the same thickness.
They also developed some truly incredible traditional joinery methods, techniques that spoke volumes about their deep understanding of material
Like
properties.
trunnels.
Exactly. Imagine those large wooden dowels, sometimes called trunnels, a charming shortening of tree nails. They were historically used to mechanically pin framing members together in robust structures like buildings and massive ships.
How did they work?
These dowels were often inserted with their grain running perpendicular to the joined parts. This created a powerful physical constraint that held the pieces together with immense strength, often without needing any additional glue or metal fasteners.
It was an elegant, almost organic solution, relying on the inherent mechanical properties of the wood itself for structural integrity and lasting durability.
Indeed. And when we shift our focus to stone and mortar, particularly during the medieval period, the quality of construction, say, in a formidable flint wall, was directly dependent upon the excellence of the mortar used.
Roman mortar, for instance, was legendary for its resilience, often described as tremendous.
Right. That's why things like Portchester Castle could survive relatively intact for an astonishing 2 millennia, a testament to its enduring strength.
However, later medieval builders, often relying on slower-drying lime mortar, faced significant and practical challenges.
What kind of challenges?
This slower drying process meant they were forced to pause construction after every few feet of wall, sometimes as little as a dozen courses, to allow the mortar to properly cure and dry before applying further pressure from above.
So it slowed everything down.
Massively. This inherent constraint frequently made winter building entirely unfeasible, as damp conditions could compromise the entire structural integrity, leading to costly failures.
That detail really transports you into the mindset of those builders, doesn't it? Dealing directly with the unpredictable elements, their pace, dictated by the very materials they used.
Absolutely. And beyond individual buildings, there's a fascinating example of early urban planning in the Bastides. Those small, meticulously planned towns that sprang up, particularly in medieval France and England.
Right, the planned communities.
These settlements were often initiated by a feudal lord or a monastic order, the bastidor, acting as a founder. The land within these new towns was systematically subdivided into standardized burgage plots.
And people had to build on them.
Yes, each man who received a plot was under a strict requirement to build his own house within a stated time, usually no more than a year. The founder, for their part, would meticulously lay out and level the streets, establish public squares, and designate marketplaces, creating a cohesive, organized community from scratch.
What's particularly insightful about the Bastides is their pragmatic approach to defense, isn't it? Which often revealed the economic realities of the time.
Definitely. Constructing full defensive walls around an entire town was incredibly expensive, a luxury often only kings, with their vast powers to conscript labor and raise revenue, could truly afford.
So most Bastides didn't have walls.
Our sources note that perhaps two-thirds of the French and English Bastides were never fully provided with walls, highlighting a more functional, less militarily ambitious approach to settlement development.
It showcases a very direct and telling relationship between the availability of resources and the ultimate urban design and defensive capabilities. How economic constraints shaped the very fabric of early communities.
It makes you think. In our current age of globalized supply chains and hyper-efficient mass production, where everything often seems engineered for speed and low cost, do we still truly appreciate the intrinsic value, the unique challenges, and the deep resilience embedded in that craft-based construction and the use of locally sourced materials?
There's a distinct beauty and an undeniable longevity there that's certainly worth contemplating beyond mere efficiency.
It's a very pertinent question, especially in an era of globalized production. And speaking of individual vision and unwavering artistic integrity, we absolutely must spend some time discussing Frank Lloyd Wright.
Yes. A true individualist.
His entire extraordinary journey profoundly underscored the immense value of staying true to one's artistic vision, prioritizing integrity over conformity, even when facing significant societal pressure and financial hardship.
Wright passionately believed that true freedom in creative work was inextricably tied to the ability to create without the crushing burden of debt and external societal expectation.
Right. Allowing for the most organic, unconstrained expression of ideas, entirely free from the fetters of traditional styles or fleeting trends.
He was never one to shy away from challenging the established order either, Wright was famously and often vocally critical of conventional educational methods.
He felt they overly emphasized rote learning and imitation.
Exactly. Instead, he ardently advocated for approaches that actively fostered independent thought, nurtured genuine creativity, and cultivated a deeper, more profound, almost spiritual understanding of design in harmony with nature.
He wanted architects to truly think, to innovate, and to discover, not merely to replicate or conform to existing paradigms.
His early life, as described in our sources, offers some fascinating clues into how this fiercely independent design philosophy developed.
Hmm.
His childhood revealed a natural, almost insatiable curiosity and an acute accuracy of observation, along with a profound, almost innate interest in what he termed constructive affairs.
He found a deep, abiding joy in the very act of building and developed an early, almost instinctual connection to nature, particularly that Midwestern landscape that would later inspire his prairie style.
It demonstrates how early experiences, infused with genuine passion and observation, can profoundly shape a design philosophy that champions individuality, organic expression, and a unique response to place.
So this leads me to ask you, our listener, how much of your own creative work, whatever field you might find yourself in, is truly free from external constraints?
From those nagging pressures of debt, the weight of societal expectations, or even the confines of established norms.
And how does that inherent freedom, or perhaps the lack thereof, ultimately influence the final outcome, the very essence of what you create? It's a question that certainly resonates far beyond the blueprints and construction sites of architecture.
Okay, so as our world became more interconnected, as buildings grew exponentially more complex, and as urban populations swelled to unprecedented densities, well, the underlying need for order became absolutely undeniable.
Things had to get more organized.
Precisely.
Yeah.
This critical shift brings us directly to the rise of standardization and regulation, most visibly manifested through comprehensive building codes.
And these aren't just arbitrary rules dreamt up by committees. They are absolutely crucial frameworks meticulously designed to ensure public safety and general welfare.
For instance, building codes now rigorously address what are termed hazardous occupancies. These are carefully categorized from H1 through H5 based on the specific type and quantity of hazardous materials present.
H5, specifically, designates facilities like semiconductor fabrication plants, requiring extraordinarily stringent construction and use requirements when quantities of hazardous materials exceed predefined maximum allowable quantities.
So it's very specific, very detailed.
Incredibly so. This granular detail ensures that even the most volatile environments are designed to mitigate risk. And these codes delve into incredibly precise detail, addressing everything from the macroscopic to the minute.
Like fire protection.
Exactly. Fire protection is a paramount concern. Firewalls, for example, are mandated to extend to the outer edge of horizontal projections like roof overhangs or balconies if those projections are situated within a 4-foot proximity of the firewall itself.
Wow, that's specific.
And there are even specific, carefully considered exceptions for building elements that lack concealed spaces, where fire spread is inherently less of a concern. Beyond passive fire resistance, active smoke control systems,
Like smoke detectors.
and crucially, carbon monoxide detectors, are expressly mandated in specific occupancies, notably educational E, institutional I, and residential buildings where there are potential sources of carbon monoxide. These are often life-saving regulations, meticulously developed in direct response to lessons learned from past tragedies and accumulating scientific understanding.
And a truly monumental shift in recent history, reflecting evolving societal values, has been the inserted movement towards inclusive design, specifically focusing on accessibility for all.
The ADA.
Right. The Americans with Disabilities Act, or ADA, standards, specifically the 2010 edition, along with the comprehensive ICC A117.1 standard, now provide rigorous federal design criteria for accessibility.
And these apply universally to new constructions, additions, alterations, and repairs, ensuring that every modification contributes to a more inclusive environment.
This includes nuanced requirements for Type B dwelling units in residential occupancies with 4 or more units, and even more stringent requirements for Type A units in larger R2 occupancies, specifically those with more than 20 units.
It represents a fundamental and legally mandated change, ensuring that our built environment is designed to serve everyone, fostering true equality of access.
And this incredible level of detail truly extends into every corner of a building. addressing even seemingly mundane elements with profound implications for safety and usability.
Like stairs.
Exactly. For structural integrity, consider something as ubiquitous as stairs. Codes mandate a minimum headroom of 80 inches, ensuring comfortable passage, a consistent tread depth of 11 inches, preventing missteps, and riser heights that fall precisely between 4 and 7 inches.
With only slight variations allowed for homes.
Right. And crucially, treads and risers must maintain an almost perfect uniformity in dimension, allowing for only a tiny tolerance of 38 of an inch, precisely to prevent tripping hazards.
That might seem like an overly precise detail, but uneven steps are a leading cause of trips and falls. So this tiny regulation literally saves countless people from injury every year.
It really does. Similarly, environmental control is heavily regulated. Underfloor ventilation, for instance, is required in non-slab-on-grade structures to prevent moisture buildup.
But this requirement can be reduced or even replaced with mechanical ventilation if a vapor retarder is present, or if the space is both insulated and climate conditioned, effectively protecting the structure from vapor intrusion and its associated problems.
It's remarkable how thoroughly they anticipate every potential issue. Even thermal performance is meticulously accounted for. Thermal barriers are strictly required for foam insulation to prevent rapid-fire spread.
Though, as always, there are carefully considered exceptions, like in utility service areas or within structural floor systems that are already adequately covered by wood structural panels.
These regulations, though they might appear mundane on paper, collectively underpin the safety, comfort, and longevity of almost every building we inhabit today.
It really is a vast, interconnected web of rules, all designed to safeguard the public and ensure structural resilience. Which leads us to ponder, how do these intricate building codes actually impact your daily life, even if you're largely unaware of their existence?
Yeah, do you ever find yourself wondering if they stifle genuine architectural innovation, or are they an absolutely essential, non-negotiable framework for safety, durability, and livability in our increasingly complex and densely populated world?
That's a perfect segue into understanding how these codes directly influence standardized construction methods and materials. When you're building today, there are very clear, deeply established ways of doing things, all aimed at consistency and quality.
Take foundation work, for instance. Proper waterproofing of foundation walls, critical for preventing moisture damage, now rigorously requires the application of drainage mats, rigid insulation, or protective boards.
And concrete ground slabs have a minimum specified thickness, right? 4 inches.
4 inches, yes, to ensure adequate strength. And the crucial joints between foundation walls and slabs need to be meticulously sealed with specialized materials like bentonite clay or robust water stops to create an impenetrable barrier against moisture intrusion.
And this standardization extends comprehensively through all the core structural elements. For both steel and reinforced concrete columns, there are highly specific requirements governing everything.
Like the rebar patterns.
Exactly. From the vertical and lateral reinforcement patterns to the precise placement of dowels, which are essential for anchoring these columns securely to their footings. Furthermore, specific concrete cover for the internal steel reinforcement is mandated not just for structural integrity, but crucially to ensure durability and sufficient fire resistance, protecting the steel from premature failure.
And when we talk about pile foundations, these are complex engineered systems, right?
Definitely. Systems of either end-bearing or friction piles, which work in conjunction with pile caps and tie beams, all meticulously designed to transfer massive building loads safely and efficiently down to suitable, stable strata deep within the earth.
Framing systems also heavily rely on these established standards to ensure stability and efficiency. With traditional wood, plank, and beam framing, there's a requirement for careful integration of supporting beams with interior partitions,
Which is a consideration both for fundamental structural support and for maintaining visual continuity and aesthetic flow within the space.
And for light-gauge steel construction, the details largely mirror those of wood framing but are adapted for steel, using elements like nested joists, precise anchor clips, and web stiffeners to create robust and reliable structures, which are increasingly popular for their strength-to-weight ratio and resistance to pests and fire.
And let's not overlook the building envelopes and internal finishes. Those are also governed by extensive standards. Glazed curtain walls, ubiquitous in modern high-rises. They aren't just sheets of glass.
No, they're sophisticated systems.
Right. They utilize advanced pressure equalization principles and tight air seals to manage air and water infiltration effectively, crucial for energy efficiency and occupant comfort.
And for interior walls and ceilings, gypsum board systems drywall remain incredibly popular.
Due to their lower cost, their ability to create a seamless, smooth surface when properly finished, and their crucial fire resistance, which offers significant protection to combustible framing materials in the event of a fire.
And critically, underpinning all of these standardized practices is a universal reliance on accepted practices and stringent quality specifications issued by authoritative organizations like ACI, AWS, ASTM.
Exactly. The American Concrete Institute, ACI, the American Welding Society, AWS, and the American Society for Testing and Materials, ASTM. These organizations provide the benchmarks and guidelines that ensure consistent quality, predictable performance, and ultimately the safety of construction across the entire industry.
So, next time you cast your eye upon any building, whether it's an unassuming apartment block or a towering corporate headquarters, maybe pause to consider the incredible, unseen layers of specialized knowledge, meticulous engineering, and standardized practices that were intricately woven into its very construction.
It's far more than just bricks and mortar or steel and glass. It's a profound testament to centuries of accumulated human wisdom, refined craftsmanship, and continuously evolving regulatory frameworks, all working in concert to create the environments we inhabit.
Okay, as we transition into the modern era, the sheer scale, the intricate complexity, and honestly, the dizzying speed of today's construction projects demand an entirely new level of sophisticated organization.
Things got complicated fast.
They really did. This is where we encounter the rise of project management, truly both an art and a science dedicated to orchestrating the entire build process.
Designing and constructing a building is no longer merely a series of individual isolated tasks. It is, by its very nature, an intensely collaborative team activity, often unfolding in a highly linear fashion.
Which necessitates a systematic, comprehensive approach, where very specific management techniques are required and applied at each and every stage, from initial concept right through to final handover.
That's a critical and often underappreciated distinction. At its fundamental core, modern construction management embraces rigorous cost management as an absolutely essential foundational discipline.
It's not just about tracking expenses, is it?
No, far more than that. It means establishing a realistic and achievable project budget that respects the owner's financial limitations, and then diligently applying specialized skills to ensure that the entire project planning, design, procurement, actual construction is executed as economically as possible.
All aligned with a detailed work breakdown structure, which segments the project into manageable tasks.
Precisely. And crucially, timely and accurate cost and time control information is absolutely vital. It empowers project managers to quickly identify any deviations from the plan and take immediate corrective action before costs or schedules have a chance to spiral dangerously out of control.
In today's competitive environment, speed and efficiency are absolutely paramount. And that's precisely where sophisticated scheduling and critical path analysis become indispensable tools.
Activity durations, for example, are meticulously determined through a powerful blend of historical experience, expert judgment, and sophisticated algorithmic calculations.
Right, trying to predict how long each piece will take.
And scheduling networks, often referred to as precedence diagrams or activity on node, AON diagrams, where activities are nodes and dependencies are arrows, are used to precisely identify the critical sequence of activities.
The ones that absolutely cannot be delayed.
Exactly. These are the tasks that, if delayed by even a single day, will inevitably push back the entire project completion date. This analysis also shrewdly helps project managers identify any inherent leeway or flexibility, sometimes called float, in non-critical activities.
Allowing for resource optimization and, crucially, preventing minor delays from quickly escalating into catastrophic project setbacks.
For truly massive, complex initiatives, the concept of project management expands even further into what we call program management.
Handling multiple projects at once.
Right. This involves developing a meticulously written program management plan, or PMP, which serves as a master reference document. This PMP defines the overarching vision, the strategic approach, the comprehensive schedule, and the consolidated budget for the entire program, which might encompass multiple interrelated projects.
And often, a dedicated program management office, or PMO, is established specifically to oversee all projects falling under that PMP.
This centralized oversight ensures continuity, maintains standardization, and facilitates efficient decision-making across the entire, often sprawling program, preventing silos and ensuring alignment with the strategic goals.
So this is where I want to connect this to you, our listener.
Yeah.
Have you ever found yourself managing a complex project, even if it's completely outside the realm of construction?
Maybe organizing a large family event, orchestrating a household move, or even preparing a detailed work presentation with multiple deadlines.
If so, you'll instantly recognize the universal principles of meticulous planning, strategic scheduling, and rigorous cost control at play here. It demonstrates how these sophisticated construction management techniques are surprisingly and powerfully applicable to so many aspects of our daily lives.
It's a powerful testament to the universality of effective management principles. And building directly on that, a significant innovation in recent decades has been the advent of lean construction.
Ah, yes, lean. Borrowed from manufacturing initially.
Largely, yes. It's a philosophy meticulously focused on optimizing workflow, delivering maximum value to the client, and critically, minimizing all forms of waste throughout the project lifecycle. A cornerstone of this approach is the Last Planner System, or LPS.
LPS, what is that exactly?
LPS is more than just a tool. It's a comprehensive specification for project production planning and control. It deliberately focuses on specific functions, underlying presuppositions, core principles, and repeatable processes to significantly improve workflow reliability and predictability across the entire project.
And at the very heart of the Last Planner system lies a technique called pole planning.
Pole planning. Sounds interesting.
This is where a detailed work plan isn't simply pushed down from above, like traditional scheduling often is. It's collaboratively developed by literally working backward from a major project milestone.
So you start with the end goal.
Exactly. It involves all responsible parties, designers, engineers, contractors, subcontractors in highly collaborative sessions. They collectively define their conditions of satisfaction for each task and then sequence activities logically, working backward.
And this is especially crucial for proactively identifying and removing any potential constraints that could impede progress.
Right. This inclusive, collaborative approach fosters a strong sense of collective ownership of the plan and creates a single source of truth for the immediate work ahead, preventing individual teams from working in isolation and causing downstream problems.
The true elegance of lean construction lies in its detailed foresight and relentless focus on problem solving. Projects are meticulously broken down into increasingly granular levels, phases, processes, operations, and individual steps.
And a crucial tool here is the look-ahead window, right? Typically spanning from 3 to 12 weeks.
Exactly. This window is used to proactively identify and systematically remove any potential constraints that might arise, whether they involve delayed material deliveries, missing crucial information, a shortage of specific skills, or even pending permits long before they can cause any delays on the construction site.
This proactive, anticipatory approach is absolutely fundamental to maintaining a smooth, efficient, and reliable workflow.
And like any truly effective system, lean construction rigorously relies on metrics for continuous improvement and learning. Key metrics include the percent plan complete, PPC.
Measuring how much of the weekly plan was actually achieved.
Right. Then there's tasks made ready, TMR, tracking how many tasks had all their constraints removed, and tasks anticipated, TA, which looks at future work.
These, along with a systematic tracking and analysis of plan failures, reflect a deep commitment to continuous learning and improvement. Often following well-known cycles like Plan, Do, Check, Act, PDCA, or Detect, Correct, Analyze, Prevent, DCA.
It's all about constant refinement based on real-world feedback and an unwavering commitment to getting better.
What's truly fascinating here is the direct applicability to your own daily life. How could consciously applying pole planning, thinking backward from a desired goal, or systematically identifying and removing bottlenecks in your own daily tasks?
Perhaps in a complex workflow at work or even a significant household project.
How could that significantly improve your efficiency, reduce stress, and lead to more predictable, successful outcomes? It's a powerful way of thinking about any complex process, professional or personal.
Which brings us almost up to the present day, and arguably the single biggest revolution in modern construction. The profound digital transformation, epitomized by Building Information Modeling, or BIM.
BIM. It's everywhere now. Our sources describe it as a demonstrably superior design environment when compared to traditional 2D CAD.
And it's not merely about drafting lines on a screen. It's fundamentally based on object-based parametric modeling.
Okay, what does object-based parametric modeling actually mean in practice?
It means that designers define individual objects, a wall, a window, a structural beam, and critically, their shape, size, and properties can all be controlled parametrically. You change one dimension, say the height of a wall.
And everything connected updates automatically.
Exactly. The entire object and any connected objects like windows or doors within that wall intelligently update. This captures design intent far more effectively, making model creation and editing incredibly fluid, responsive, and ultimately far more intuitive than ever before.
What's truly foundational here, though, is that BIM is, at its very core, a highly intelligent digital database.
More than just a 3D picture.
Much more. Within this database, every object, every space, and every characteristic of a facility is meticulously defined and stored. This enables the BIM model to serve as a comprehensive living virtual representation of a physical facility.
Capable of supporting a vast array of qualitative and quantitative analyses throughout every stage of the project lifecycle. It moves far beyond mere geometry, encompassing rich, intelligent data about every single component and its relationships.
And the payoffs from transitioning to BIM are immediate and significant, even with partial implementation. Firms that adopt BIM consistently report substantial benefits.
Like fewer errors.
Definitely, including a dramatic reduction in drawing errors thanks to the inherent consistency and automatic updates of a central integrated model. They also see improved engineering productivity and, crucially, the elimination of incredibly costly design errors caused by spatial interferences.
Those nightmare scenarios where, say, a HVAC duct might conceptually run directly through a structural beam in separate 2D drawings.
Right. A BIM model, by contrast, would immediately flag that conflict, that clash, allowing it to be resolved digitally before it becomes a devastating, expensive problem on the construction site.
This brings us to a fundamental and transformative benefit: enhanced communication. Because BIM models are inherently 3D and provide a visually rich representation that is much closer to everyday reality than abstract 2D plans.
They drastically facilitate communication among all project actors. This includes owners, architects, various consultants, general contractors, and specialized fabricators.
It genuinely provides a visual, interactive, single source of truth, allowing everyone involved to understand the design intent, visualize potential issues, and make informed decisions with an unprecedented level of clarity.
This shared understanding minimizes misunderstandings and streamlines the entire collaborative process.
So connecting this to you, think about any collaborative project you're involved in, perhaps far beyond just construction. How could having a truly interactive 3D model, a singular visual source of truth that everyone can engage with and understand,
How could that fundamentally prevent misunderstandings, streamline decisions, and ultimately improve the outcomes of your own collaborative endeavors? The underlying principles are truly universal.
expanding on those capabilities, BIM truly offers an incredibly powerful suite of tools that redefine the design and construction process. For sophisticated engineering analysis, it enables a myriad of performance simulations.
Like structural testing.
Yes, rigorous structural analysis to test load-bearing capacities under various conditions. Detailed energy consumption analysis to optimize building performance for sustainability and cost. And even intricate daylight analysis to ensure optimal occupant comfort and significantly reduce the need for artificial lighting.
This comprehensive simulation capability profoundly enhances the efficiency and efficacy of the design process, allowing for data-driven, informed decisions to be made much earlier in the project.
And one of its absolute killer apps is clash detection.
Finding those interferences before they happen on site.
Exactly. This critical BIM process actively and automatically checks for interferences by searching for intersecting volumes within the model. It has the remarkable ability to combine multiple models from disparate sources.
Like the architect's model, the structural, the MEP.
Right, all within a common digital environment. This allows project teams to identify and resolve conflicts digitally long before they escalate into incredibly costly, time-consuming, and frustrating problems on the physical construction site, saving immense amounts of time and money.
The benefits extend powerfully to scheduling as well, giving rise to what we call 4D schedules.
4D, so adding time.
Precisely. Here, the fourth dimension adds time to the 3D model. This is achieved by dynamically linking Project Critical Path Method, or CPM, schedule activities to the specific 3D objects in the BIM model.
Which provides a graphically rich and animated representation of the planned construction sequence over time.
It's an exceptionally powerful tool for visualizing complex phasing, coordinating intricate work between trades, communicating the construction plan clearly to a diverse range of stakeholders, from the client to the on-site crew.
And even for running what-if scenarios to test alternative sequences or mitigate potential risks.
And then, building further on this, we have 5D cost management.
Adding cost is the fifth dimension.
Exactly. Here, the fifth dimension integrates real-time cost data directly into the model. Every element within a BIM model can be meticulously attributed with its associated resources and respective costs.
This capability allows for highly parametric and dynamic quantity takeoff for bills of materials, meaning that as design changes are made, the material quantities and associated costs are automatically updated.
Leading to far more accurate and dynamic estimates, and crucially, providing real-time value tracking as the design progresses, giving project stakeholders an unprecedented level of financial insight and control.
This deep integration also dramatically enhances interoperability, which is the crucial ability to pass data seamlessly and accurately between different software applications, allowing multiple programs to jointly contribute to the work.
Which eliminates the tedious and error-prone process of manual data copying. It actively encourages design iteration by making changes easy, and significantly reduces inconsistencies and errors that plague traditional workflows.
The real-world impact is profound and tangible. One fascinating case study showed collaboration supported by parametric modeling, drastically reducing the number of unique cladding panel lengths required for a project from an astounding 4,114 distinct lengths down to just 53.
Wow, from over 4,000 to 53, that's absolutely incredible. Imagine the optimization in production, procurement, and installation costs that this kind of reduction can deliver.
A tangible, powerful example of how digital transformation drives efficiency.
So I urge you to think about this. How might the ability to simulate and visualize a project's entire future, from its precise construction sequence to its detailed cost implications, fundamentally change how you approach planning and execution in your own life?
It truly represents a complete paradigm shift in foresight and proactive management.
This revolutionary capability leads us to some fascinating speculations about the future of building, extending far beyond just the digital file itself.
Some forward-thinking individuals propose that we are steadily moving from a world of largely remote control, where things are predetermined from afar and centrally managed,
To one where increasingly sophisticated digital fabrication technologies dramatically increase personal and community self-sufficiency.
Imagine fab labs, local fabrication laboratories, not just making consumer products, but designing machines that can make other machines, enabling localized creation, fostering new forms of skill building, and decentralizing manufacturing in powerful ways.
That truly is an empowering vision, a democratization of creation. And with the increasing ubiquity of computing, urban life is witnessing a profound convergence of physical and digital space.
This could realistically lead to genuinely smart cities, where citizens are not merely passive recipients of services, but actively engaged in collective action, empowered to transform their own environments.
Moving beyond purely top-down, centralized frameworks to more dynamic, responsive, bottom-up initiatives, where citizens themselves are actively empowered to shape and adapt their urban fabric, fostering a deeper connection to their built surroundings.
And this brings us back to a timeless, fundamental human principle: continuous learning. Just as a truly skilled carpenter refines their craft by meticulously fixing the things that I did when I was younger.
Learning from mistakes.
Exactly. The design and construction professions urgently need constant feedback loops, rigorous failure analysis, and a commitment to iterative improvement to truly thrive. It's about continuously learning from the nuanced realities of built structures, analyzing what works and what doesn't.
And using that invaluable knowledge to refine and perfect design intent, ensuring that our buildings and the sophisticated processes we use to create them are always evolving, always adapting, and always improving.
So as technology makes it ever easier to design, prototype, and even fabricate complex structures locally,
Yeah.
what truly profound implications does that have for traditional large-scale construction?
And perhaps even more fundamentally, how might it irrevocably change our very relationship with the objects, the spaces, and the structures that define our daily lives? It's a future where the act of building could become even more intimately intertwined with community engagement and individual agency. Hashtag outro. Wow, what an absolutely incredible journey we've undertaken today.
It really covered a lot of ground.
We've traversed vast stretches of human history, haven't we? From the thoughtful artistry and precise reason of ancient Greece, the imposing engineering prowess of Rome,
Through the hands-on craft traditions of medieval builders.
moving past the essential era of standardization and regulation,
And finally, arriving at the complex, interconnected, and increasingly digital world of modern construction management and, of course, BIM.
and what truly stands out, I think, consistent across all these centuries and profound technological leaps, is the persistent, defining human challenge.
How do we accurately, clearly, and compellingly translate an abstract idea, a pure design intent, into a tangible, built reality that stands the test of time and function?
The methods for achieving this have transformed dramatically, from intricate, hand-drawn plans requiring immense skill and interpretative genius.
To sophisticated digital models that can simulate and predict virtually every detail imaginable.
Yet, the core act of imagining and then manifesting that imagination into something solid, something real, something that shapes our world, that remains an unchanging, fundamental human drive.
It's a profound, almost innate human impulse. And this leaves us with a truly provocative thought to ponder as we conclude our deep dive.
If cutting-edge digital tools can now predict performance, detect clashes, and even manage costs with incredible accuracy before a single brick is laid, what happens when the design intent itself becomes fluid, constantly refined and optimized by real-time data and dynamic simulations?
Will the very act of building evolve into an ongoing digital feedback loop, a perpetually iterative process?
And if so, how will that fundamentally transform the very definition of architecture, redefine the essential role of the designer, and reshape our timeless human desire to create and construct?
It truly changes the relationship between vision and realization, blurring the lines in fascinating ways. Thank you for joining us on this deep dive.
We'll catch you next time.